Hello, hello. Today's video is on scatter plots. What is a scatter plot and how do we use a scatter plot? First things first, a scatter plot has points that show the relationship between two sets of data. Basically, a bunch of points on an x and y coordinate plane. How to use a scatter plot? You use the points in the scatter plot to identify correlation. There can show positive, negative, or no correlation. Positive. A scatter plot shows positive correlation when the values increase together. Negative. A scatter plot shows negative correlation when one value decreases as the other increases. And no correlation. A scatter plot shows no correlation when the points on the scatter plot are everywhere. So to show you what we mean, we have some examples. We have 3 examples of a positive correlation. As you see, the first one is labeled a perfect correlation. As you see, the points go into a perfect line. Next one is a highly positive correlation. The points are generally close together, forming a line, and a low positive. The points are a little scattered, but again, they still are increasing. And we can tell it's a positive correlation because you go from the bottom left up to the top right. This is a positive correlation. You can literally draw a diagonal line through it, going up. Now a negative correlation, as we can see, we have 3 different types. We have a low negative correlation. The points, if you can draw a line going from the top left to the bottom right, they're kind of close together, but not quite. High negative correlation, these points are really close together now, and you can easily see the line that they form. In a perfect, now it's obvious the points are forming the line, and that's a negative. Negative correlations go from the top left down to the bottom right. And finally, no correlation. As you can see with this graph here, the points are everywhere. It basically looks like a bunch of polka dots every random which way. Now, if we take a look, we have some examples here, problems 1 through 6, and we're going to go ahead and determine which one's positive and which one's negative. And I'm going to show you how we can do this. Now, this is pretty easy. All we have to really do is draw a line of best fit through as many points as possible. So for each one of these, we're going to draw a line. For the first one, since the points are everywhere, we really can't. But for the next 4 you can, but 6 is also one that you really can't. You can draw a circle, but you can't really draw a line. So we're going to draw a line of best fit through the ones that we can. Once we draw a line of best fit through the ones that we can, we're going to take a look at these lines and determine if it's a positive or a negative. So classify the correlation. And again, positive, the line goes from the bottom left to the top right. And as you can see, 3 fits that, and so does 4. So we're going to mark those as positive. Negative correlation line goes from the top left to the bottom right. So top left, bottom right. So we see 2 and 5 are definitely that. So we're going to mark those as a negative. And no correlation, you can't draw a line of best fit. So 1 and 6, you couldn't draw a line. So those are no correlation. So to recap, to determine positive, negative, no correlation, you just draw a line of best fit to the points. If it's sloping upwards, it's positive. If it's sloping downwards, it's negative. And if you can't draw a line, it's no correlation. Alright, so we're going to take a look at an example here. We have a scatter plot. And according to the problem, the coaches of a group of debate teams answered a survey about hours of debate, team practice, and the number of team wins. The graph shows the results of the survey. Now if we take a look, the x-axis represents the hours of practice per week. The y-axis represents the debates won. And we have a bunch of points in between. Now we have 2 problems. A scatter plot indicates which of the following. And number 2, based on these results, if a team practices 4 hours per week next season, which is the best estimate of the number of debates the team can expect to win? We're going to take a look first at problem number 1. Now, again, this is determining, well, if you look at the answer choice questions, positive, negative, no correlation, parallel correlation, well, we can automatically cross out D because we didn't talk about that. So what we're going to do is draw a line of best fit through it. So we're going to go ahead and draw our line. And what we see here is a positive correlation. Again, we can determine that because it goes from the bottom left to the top right. And as you can see, I have the definitions of positive, negative, no correlation, or what they look like to the right. So what we're going to do is label that positive correlation, and we take a look at our answer choices. And we can easily see that answer choice A is our correct answer. Now let's take a look at the next one. Problem number 2. Based on these results, if a team practices 4 hours per week next season, which is the best estimate of the number of debates the team can expect to win? Well, to kind of determine this, what you're going to do is make a prediction, and how we're going to do that is by drawing in line a best fit through the data. Once we have that line, wants to know what's the prediction for 4 hours, we can draw a vertical line from the 4 hours from the x-axis up to touch that line. Alright, now that we got that, we need to figure out the possibility of how many they're going to win. Well, the number of wins is on the y-axis. So we're going to draw a line from the y-axis to the point of intersection between the line and the 4 hours. Okay, we're going to draw that. Once we have that, we have the exact point on the line, and we can easily see that the y value of that point is a little bit above 16. Now, keep in mind this is a prediction, so it's not going to be an exact answer. So we're going to take a look at what is the closest answer in our answer choice. So identify the value found by the horizontal line. It's a little bit above 16. And so we're going to take a look at our options, and we see that the closest one, choose the best answer, the closest one is going to be 17. So, sorry, 16 is the closest to 17. So, answer choice B is the closest one. So we're going to go with that. So we have our choice. So, to review what we did, we first, for any comes to prediction, draw our line of best fit, and then we drew a line for the number of hours, because that's what it wants. What's the prediction for 4 hours? And then we drew a line from the intersection of the line of best fit and that over to the y to figure out what the prediction would be. And that's how we ended up with B16. So we know it's a positive correlation, and if they practice for about 4 hours, the answer is going to be about 16. Again, it's a prediction, so you got to pick the best answer out of the bunch, or the closest one. Alright, so right over here, this is another example of what might happen. Michael went on a bicycle trip. The scatter plots below show the distance she had traveled from various lengths of the duration of the bicycle trip, which equation describes the line of best fit for the scatter plot. As you can see, we have the scatter plot to the left. The x-axis is time in minutes. The y-axis is distance in miles. And we see the title is Michael's bicycle trip. I'm sorry, Michelle's bicycle trip. Alright, we have our answer choices, and now if you notice, our answer choices are linear equations. Alright, and it wants to know which one of those actually represents the line of best fit. Well, to determine that, you're going to have to graph each equation over the scatter plot. So once we graph them, as you can see, I graphed them, and we have our graphs right there. Once we have them graphed, we're going to have to identify the graph displaying the line of best fit. So in other words, we're going to see which line graphed is really closest to the points. And examining through them, we see B is nowhere close, C is nowhere close, D is nowhere close. You can barely see the line of D because it's so high. A is the only one that's right there. So we know A is definitely that line. And because of that, we know our answer is A. Now, I don't mind if you want to use a graphing calculator to graph it to see which one's going to be the line of best fit, or you graph it by hand, but just to let you know, you have to graph and see which one's closest to points, or which line formed is closest to its points. So again, our answer here is A. Alright, so what we have now are, Alright, so what I have now is an example problem. I want you to go ahead and try it on your own. Once you have your answer, I want you to unpause the video after you pause it when I tell you to. So go ahead and pause now, and I'll be waiting. Alright, welcome back. So we're going to go over the answer a little bit later. I have another problem I want you to try first. So as you can see, I have another problem here. I want you to pause it when you have your answer, unpause it, and we'll go on from there. So go ahead and pause now. Alright, welcome back. We have two more I want you to try. So here's the second to last one. I want you guys to go ahead and try this one out. Once you have your answer, unpause the video after I tell you to pause, and we'll move on to the last one, and then we're going to go over the problems. So go ahead and pause now. Alright, welcome back. So, last problem. Once you have your answer, I want you to unpause, but go ahead and pause now. Alright, welcome back. So we're going to go ahead and take a look at the very first one. Now, this one right here, as you can see, you have a graph of car scratches, and as you can see, the x-axis age of car in years, and the y-axis number of scratches. So if we take a look at the question, based on the line of best fit, which is the most it's supposed to be likely, which is the most likely the number of scratches that could be found in a car that is 30 years old. So if we take a look at the line of best fit and the 30, as you can see, 30 is the last tick mark on the x-axis. As we see where they intersect and go across, you see that's going to be a little bit over 80, somewhere between 80 and 90. So it's definitely going to be C. And as you can see, our step-by-steps are marked right below. Extend the line of best fit. Draw a vertical line. Well, that's vertical line from the x-axis where it represents 30. From the line of intersection between those two, you're going to draw a horizontal line to the y-axis to see what the y value is. And that y value is going to be your answer. In this case, it's going to be C, 87. All right. The next one, as you can see, we got another graph titled Spots Weight. Underneath that, the x-axis, age in months. After that, the y-axis says weight in pounds. And it says, based on the line of best fit, what will be Spot's weight after 18 months? So as you can see, I have the steps right below that. First, draw a line of best fit. Then draw a vertical line from the x-axis where it represents 18 months. So you're going to see that 16 is the end, but so you go a little bit further and kind of draw a line that's off the graph a bit and see where they intersect. From there, you're going to draw a horizontal line to the y-axis. And once you do that, you can identify the value from the y-axis, and it's going to be about 32. So it's going to be about 32 pounds. Alright, so the second to last one right here, we have the spot weights, age in months, and weight in pounds. Which equation best describes the line of best fit? Remember, this one's always going to be a pretty easy one. You're just going to graph each of the equations and determine which line is closest to the point. And that is going to be D. D is going to give you a line that's closest to all the points. Alright, the final question. What is the correlation presented by the scatter plot shown? It's either going to be A, positive, negative, relatively no, undefined, and none of the above. So all we're going to do is really look. And if we take a look at the line, it's going from the bottom left-hand corner to the top right-hand corner. And because of that, that's the definition of positive, so it's going to be a positive correlation. Alright, so that's it. Have a great day. I look forward to seeing you next time.